Welcome to 20 Minutes with Leon, and every week, our special guest. Brought to you by Bio360 Expo, this is the podcast that shines a light on the movers and shakers of the bio-transition and their vision to lead us to a vibrant, sustainable, circular bio-world, one where life goes on. So, Harald Bier, welcome to 20 Minutes with Leon.
Thanks for having me.
Great to have you with us, Harald. And let me say, you manage the growing team at the EBI, the European Biochar Industry Consortium, where you dedicate your time together to, as I took it from the website, the key three messages: alleviating market entry barriers, ensuring sustainability, and the scaling of biochar. And I just want to ask you, and all because?
Well, mostly because I seem to have found the job where I can have the biggest impact, at least the biggest impact I had before. I'm driven by doing something to limit climate change that we're facing to a possible minimum. And if you read further, I think it's even written on our homepage that our declared goal as an industry association is to lead biochar and pyrogenic carbon capture and storage to climate relevance. And we want to do that by sequestering 250 million tons annually of CO2 before mid-century.
Okay, and that's obviously a significant number and will make a difference. So that's the big picture. But as I recall and as I have seen from your posts on social media, you're also the kind of guy who likes to roll his sleeves up and get your hands in there. So can you tell me, please, your story and your pathway that has led to where you are today? And do you still manage to get your hands dirty and get them into the biochar itself?
Definitely a little less. To my story, I was lucky enough to learn from some of the pioneers in biochar. And then I worked a bit as a consultant in that field, and I got into development cooperation and humanitarian action, where I could make quite a great progress with biochar applications. Mm-hmm. So I was working in several disaster risk management projects where we used biochar for erosion control and highly productive horticulture and agricultural projects. And then this aspect of climate change mitigation became more and more relevant to decision makers. And in parallel, an industry developed here. So this being basically a long-term carbon sink, what the biochar is, it got a lot of interest from different sides. And through that time also, I moved towards Europe again and found this job at EBI, where I think now I have the more interesting impact, at least from my side, at this European level than I had before in the international projects. Yes, I did get my hands a lot more dirty working with small-scale farmers and communities, but well, it depends on the type of char. Some of them are quite hard to get off, depending on the granular size. But I'm not working in projects so much anymore. No, we have one project here at an animal and nature park where we do composting with biochar production application. This is a little bit on the grounds work still.
Okay, so you managed to get out there and see things on the ground a little bit, nonetheless.
Oh, definitely. Also, if I'm visiting members of ours or so.
Right, of course, and so your involvement with biochar predates, in fact, the current interest levels. Would you say that it's coming out of the shadows today and into the main limelight?
I think it has actually stepped out into this light. It used to be somehow rather unknown, and if people noticed or knew something about biochar, it was mainly related to Terra Preta. Yes, I've heard something of those ancient Amazonian soils, and wasn't it that thing? While now I get more questions of how do I apply it in my particular material? So how do I make it work in concrete, or a lot more specific, or how does it work with those carbon sinks, which is now an important factor. So and we have quite some interesting growth and developments here in this field. So I would say we just stepped out. So now we're there, and now we have to grow.
Okay, and in fact, maybe before we go too far into the subject, maybe we should just take a step back, and maybe I should ask you exactly what we haven't said it. So, what exactly is biochar, and how would you put it succinctly? What biochar is?
Well, if you want to have it in one word, I would say biochar is CO2 captured by the energy of the sun and turned into a solid form through plant growth and a technical process, which is pyrolysis. So that is one sentence, but a long one. We have certain steps. One is photosynthesis. Plants take up CO2 and they grow. This material, or parts of it, the residues mainly, are pyrolyzed, which is a technical process that converts those COH bonds into a solid form of carbon. And this solid form of carbon is biochar.
Okay. And when you say plants, it's any kind of organic growth, any kind of plant matter that can be pyrolyzed in theory. Is that correct?
Yes. Even bacterial organic matter. So if you have digestate from anaerobic digestion, and you have those residues, you could pyrolyze them. Sometimes they have larger quantities of plastics, micro or larger pieces, and you wouldn't want to use them directly in agriculture. You can process them, still keep the most of the nutrients, and use this product as a treated product in agriculture as a very smart way.
Okay, so it's not just natural plant matter; it's also plant matter which has been processed in some way that can also then be pyrolyzed to create biochar.
Yes, and so animal byproducts, manure, for example, if you have too much at one place.
Okay, and this biochar you mentioned, you said it's about carbon. This whole biochar thing is about carbon, and it's about fixing carbon or getting it into a concentrated form. And therefore, I imagine we're talking the opportunity for carbon sinks through biochar. Is that correct?
Yes, it's a very important factor of the success at the moment. So the largest part of this carbon in biochar is very similar to the highest ranking forms of organic carbon that are occurring in the environment, which would be anthracite or meta-anthracite or diamonds. And if you're not a geochemist, you know it from a James Bond movie where they said diamonds are forever. And that's kind of true for the most part of the carbon in biochar also. They cannot be degraded, and if they are prevented from burning, for example, because you use them in soil or in concrete, the former CO2 is bound as pure carbon and remains over very long periods of time. And this is a carbon sink because, as I said before, it was CO2. It has been transformed. Pyrolysis, photosynthesis, then pyrolysis, and then it's applied in a carbon-conserving way. So we have a carbon storage.
I see. And just to explain around that, pyrolysis is the application of heat. In fact,
pyrolysis is an application of heat. It's kind of if you want to get from a point where what people people know is burning is with lots of oxygen, and if you limit oxygen but you continue to apply heat, then you have a pyrolytic process. Things turn black, but they don't turn to ashes.
And I think that's the key of it all.
Yeah. Yes, and it's actually an exothermal process. So you can use the heat that comes out of the process to heat up the material. So don't be confused and think we have to apply heat in order to get this process running.
Right. Okay. We generate heat, in fact, which can be used.
Yeah.
However, whatever the application.
For district heating, for process heat, for industry or so.
Okay, perfect. So we know now how to get from a plant matter, vegetative state of some sort to biochar. So once we've got our biochar, you mentioned a few things earlier, but starting with Terra Preta, and then you mentioned some other ways in which biochar can be used. But can you maybe give us an overview of all the different options there are with biochar today, and maybe a few perspectives of what we can possibly anticipate to come tomorrow, and who are the beneficiaries of biochar, in fact?
Well, all the options, that would be exhaustive. I think we would need a separate session for that, but I can wrap up a little bit or give a brief overview of the different fields of use. I guess the beneficiaries are generally all of us. As I just said, we are creating carbon sinks, but there are, of course, also particular beneficiaries. So the main field was and still is, I would say, agricultural applications. And this is animal feed. It's an additive to manure or slurry in agriculture. Stable bedding is an interesting option. You can do many good things within stable or on a field. Improve yield, improve water holding capacity, nutrient retention. You can prevent leaching of nitrate or nitrogen in general. So this is agriculture. It covers quite a vast range of applications. Then you have urban applications. Some people know the Stockholm model of tree planting. For example, in Stockholm, no trees planted without biochar, just because it makes a lot of sense. And it's an economically viable model, as trees are really expensive and the biochar helps them survive even through prolonged dry periods. Also parks, park areas where the grass is rather stressed through many people using these areas. You can design quite interesting and beautiful landscapes that are a lot more resilient to climate change and to the circumstances. And you also can filter pollutants in those urban environments that are coming from traffic, for example, from cars like chromium or PAHs or so, that don't get into the groundwater. So many benefits in that sense. And then next field of application would be materials, which is just a vast field. You have concrete, where you can make climate positive, even concrete, asphalt, so construction materials, insulation materials, but also polymers. Even 3D printing is done now with biochar and certain binders, let's say. So that's an exhaustive field. We can even think about consumer goods, biodegradable material for agriculture, for example, that degrades and leaves just biochar behind, which again is even a carbon sink, even though the material itself is short-lived. And then there are those industrial applications where carbon, like really basically pure carbon, is needed, like the silicate production as a reduction agent. They need carbon, and they normally source it from fossil sources. And this is also possible to use biogenic carbons for that in the form of biochar. Silicate, for example, would be for photovoltaic panels production, or so something really essential also to counter climate change.
Right. So that is quite an array of applications that you've mentioned there, and I can quite believe also that there are people beavering away in research institutes today, and we might even see more novel, even newer ideas for using biochar in the future.
I guess we've been there together in Italy, in Florence, for example, where people were talking about the next generation of batteries, where they also substitute fossil carbon through biogenic carbon, right? Biochar. So that's it's entire research institutions just treating that topic.
Yeah, and I know in the Netherlands they're also working on the same subject.
Yes.
So these are ways in which we can see maybe new applications coming through in the future. So it's a pretty exciting time for biochar. I think you'd agree. What is the general sentiment within the industry today? Those who have been the pioneers and the people, the advocates of this subject for many years. How do they feel? What state do they find the biochar market in today? How do they feel? What are we at the beginning of?
Well, I can talk for the people I'm normally in contact with, which is quite a broad range, and I think we all feel the same. We just stepped into the light, as you formulated it, or we did together, and this development that we're facing now is due to several factors. One is equipment suppliers. You have systems that are now TRL 8 plus. So those, you install them and they run 8,000 hours per year. So continuously. And the time for installation is really reduced. So it's ready. So this is not really an issue anymore. So actually, we're facing so many new systems that are coming up, very interesting developments for every size and use case you have. Then the other point is information got through that biochar is a product family. It's not one product that works or not. You have to find your specific product, but then you can really do something with it and use the potential that it has. We have a growing number of use cases. Then we have the carbon markets. I said that this carbon sink that the biochar also represents, it boosted the economy and the demand, because also the prices of biochar dropped because it's a co-production of carbon sinks, which are quite valuable. So and at the moment we also have the currently raising energy prices. And as I also mentioned before, we produce energy, certainly heat, but in many cases also electricity. And this is renewable energy from residues that can be sourced in the local environment, which also is very beneficial, I would say, to municipalities or to certain actors that are now relying on gas or oil. Mm-hmm. And this leads to an 80% annual growth last year almost. And this year we are topping it. And next year we're also facing 85%.
So, right. So those are interesting numbers. And they do suggest that the biochar is on this route to taking off and to scaling. But if you like, I'm going to slightly play devil's advocate here, and interested to hear what your reply will be, because if we think of other nascent sectors that have emerged from the wings and have come into the limelight, there's this period of rapid growth and scaling up, but there can be risks associated with that in terms of the speculation and the overpromise and the underdelivery. So, in terms of biochar and being in this position, what is that? Do you see that as potentially a risk with over expectations, or do you maybe see there might be other risks in related to biochar as it attempts to scale up and become a widespread industry? How would you? What risks do you see today, and how would you say the industry can and is or should be managing those risks before we hit them?
That's a very interesting question. I would say generally one of our problems is that we are too complex. We are not just this single solution. Like we suck out CO2 out of the atmosphere and put it into geological reservoirs, which is very straightforward and doesn't have so many niches and nuances to it. But with regards to risk, I think it's rather a strong point, because there are different sectors in this industry. And if we're talking about biochar, as I said, we're talking about a product family. So we need, in a defossilized economy, we need carbon. We will continuously need carbon.
Of course.
And you just produce this type of carbon. The best way to do it is through, with the energy co-production out of biogenic materials. And so this is a, I would see this as a fact. And then with the different use cases, I mean, you can improve materials and just make them more functional. We are doing this now with carbon black, for example, so also fossil carbons, which we want to substitute. We have agricultural uses. So let's say if a certain type of use case is not as popular anymore, it doesn't mean the game over for the entire industry. It just means that this sector is not maybe prospering as well. At the moment, I don't see it yet, but there might be some. With you talking about speculations, the most apparent case might be carbon certification, because this is a very young market per se, and people don't know in which direction prices will go. So there is quite a large margin, but just at the moment, biochar is from the technical solutions, technical and permanent solutions, we're by far the cheapest if you compare the prices that other technologies are offering. So again, I guess we're in a interesting situation. If you would build your business model now on extremely high prices of carbon credits, and you need those, and they won't come in the very near future, that might be risky. But that's not for the industry, it's just for certain business cases.
There are a number of areas in which biochar is being tried and applied, and you're saying, and it makes sense that some of those will fly, some will take hold more than others. But the strength that biochar has is, in fact, therefore, in its diversity. In that there may well be some as we said, some applications that are niche and some which are mainstream, but the fact that it has these different areas of application means that as a sector as a whole, there's risk mitigation in this diversity, which is different maybe from quite a number of other industries that are kind of at this hitting this moment of rapid growth, whereby it's all their eggs in one basket, but in fact biochar has a number of eggs in a number of different baskets.
Exactly.
Okay, so there's cause for optimism and hope there. Of course, it's always good to know what you're getting into and to feel that you be confident that we can really make it work. So that's a good thing. And then I know obviously the COP process with the inclusion of biochar by the IPCC as one of the 6, I think it is today, negative emission technologies recognized by the IPCC, and biochar being one of them. Therefore, at the COP, it's a subject which is getting more and more attention. You've just come back from COP27 in Egypt only a week or so ago. Can you tell us how all that works in terms of being there to represent the industry? And did you get any difference? How have you felt that the level of debate has been this year compared to previous years? Yeah. Give us an overview of the COP situation, please.
So the general achievements at COP, I think they're quite limited. Maybe this is also based on the preparation work before. So what's important to us, the carbon removals, Article 6 or 6.4, there was not too much achieved there, I would say, and in general, I would say I was hoping for a lot more at this COP for our climate. On the side of biochar, I was really surprised. I didn't have such high expectations, but because the COP before in Glasgow, I had to explain what myself basically during every conversation. What is biochar? Where can you use it? And tell people that it's basically carbon, and they should treat it like carbon, and not as, maybe if they heard of a soil additive, as only that. And but this was quite intensive work to be done to explain people what you're talking about, and then you might get into a smaller discussion within the limited time you had. And this time it was a very different scenario. It was that I mentioned who I am, where I'm coming from, and people directly were interested, and almost all the time in a very positive way, and wanted to know what they can do within their projects, in their processes, how they could apply it. And well, what I'm doing generally is just getting them in contact with the respective people. And then for IPCC, I mean, I think it was good to us because we managed to get in contact with several people that are working on it. And I think there we have still quite a way to go, because biochar is not recognized as an energy producing technology or so. It's basically, they start with the material and mainly think about soil application. And I think there is still a way to go, because if you look at the entire potential that this technology has, I would consider it a lot higher than it's mentioned, or it's named or declared at the moment in the IPCC. If you look at the whole process and energy production, and the broad range of applications and also input materials.
Okay, so you've seen that's definitely a positive evolution over the period of 1 year, and let's hope the next year that everybody will come back and saying, yes, we now we do biochar in significant numbers, and then we know we'll be there.
at least we have a team that's looking at it a bit more in detail.
Yeah. Okay, super. Okay, Harald, thanks very much. I think we've covered a lot of ground. Is there anything else you'd like to maybe say that you feel you want to say about biochar before we sign out?
I think you've asked quite a range of questions. I think I've talked a lot, and I just hope that it was understandable.
The idea.
Yes, thanks. No, so actually I'll be there at the Bio360, and I'm happy to chat there with anybody that's interested.
Super. Well, we're looking forward to the event and for that opportunity that people have to meet and exchange and making sure that we have a future and that our future generations have a future as well. That's why we're doing it.
Exactly. Yeah, one thing is maybe if somebody would want to follow us on LinkedIn, European Biochar Industry Consortium, there you can get a bit of information maybe beforehand, before we meet in Nantes.
Super. Okay, Harald. We were talking to Celia Sappart of CO2 Value Europe last week, and touched on how language is evolving around this whole subject. And we talked about the coalface is an expression that we used a lot to say people are working at the coalface. And today we should adapt that and say, well, we're defossilizing, so we're working at the bioface. And I'm just thinking, you mentioned before, diamonds are forever, and it made me think of another expression which is also used, which is diamonds are a girl's best friend. And without getting into the gender politics of that, I think, maybe a more modern way of looking at that would be that biochar is everybody's best friend. So maybe we can write a new dictionary around climate change and defossilize some of our language as well as defossilizing everything else. So from now on, biochar is everybody's best friend.
Yeah,
super.
The kids' best friends.
That's right. Okay, we'll put that on our website. Okay, Harald. Well, thanks very much again. It's been great talking to you, and we'll look forward to seeing you in person in Nantes in February.
Thanks, Paul. It was a pleasure.